So before going into the session, I just want to introduce about the Coursevita, who we are, what we are doing. I just want to introduce. So first of all, my name was Tirnath. So I'm very excited to introduce you to the Coursevita. So we are an tech company founded in 2021 with a mission to provide high quality, accessible learning to all. Okay. So it is an edtech platform. So we are basically providing quality learning to everyone. So let me go. So we actually founded in 2021 as an edtech company to provide high quality accessible learning for all. So mainly we are focusing on our transforming education through interactive courses created by the industry experts. So courses means like data science, DevOps, AWS, DevOps with AWS, data analyst. These interactive courses we are providing based on the industry experts, whatever they are suggesting. Based on that, we are focusing on particularly what are the courses that were booming in the present market. Okay, so mainly so far we have achieved like we have 10,000 learners plus worldwide and 20,000 plus career sessions was counseled, and we have 5,50,000 YouTube views, and there was so many students, 1,000 plus students was placed in various industries from our organization. Okay, so these are our main achievements during the past 1 year. Okay, and we are offering different programs as well. So these are our leaders. Hemant is our CEO, and Arjun Vinay is our director. Okay, and whatever we are offering, like we are offering courses. Other than this, we are offering a free career counseling sessions and projects as well, hands-on projects to help learners gain practical experience. So if you are learning any course, if without any practical knowledge, it will be not no use. So basically we are offering projects and career counseling sessions as well. So you can choose your career counselors and projects using our website. I will let you know how to do that thing. So once you visit our website, you can book a career counseling session and you can select a projects as well. Okay. And finally, this is about the course vita. Just I will introduce. I will just share my course vita website. Just go to the course vita website. So you can choose here in the projects and the career counseling session. If you see the projects, what are the projects we are offering? That every projects you can select using this. Okay. And if you want to book a free career counseling session, it's a career counseling session. So our industry experts career counselors will give you an idea roadmap for the courses. So you can click on this free register now. Then it will be showing a calendar like to book a slot. Okay, I think the blog schedules the appointments already booked. I will check with the team like when it will be open. So if you want to book a career counseling session, just click on this join sessions and you can register, and you can get a free mock interviews as well using our website as well. Okay, yeah, and finally that's it for the course vita. I hope this session regarding this blockchain session will be very helpful to you. I'm handovering the session to the Lakshmi, so she is the mentor for your session for the today. Yeah.
Yeah, okay. Thank you, Trinath. Hello everyone. Good morning, all of you. Welcome to today's session. Today we are talking about Web3 and blockchain. So, myself, Lakshmi, I'm working as a research and development engineer at Kerala Blockchain Academy. Let me share my screen. So I think I'm audible to you and my screen is visible. If you are facing any issues with the sound and screen, please let me know. And if you have any doubts regarding the sessions, you can ask me why during the session itself. Okay. I'm Lakshmi. I'm working as a research and development engineer at Kerala Blockchain Academy. So about Kerala Blockchain Academy, we are the Center of Excellence under Digital University of Kerala. So we are Center of Excellence under Digital University of Kerala. And we are the official partner, training and development partner of various blockchain-based organizations. So let's welcome to today's topic. Let's start today's topic. So I want to know what you heard about the term Web3. So Web3 is a very trending topic or very interesting topic. It's a buzzword now. So what do you hear about Web3? What is this concept of Web3 about in your sense? So anyone want to share your views? You can share. So, anyway, before directly going to Web3, let's talk about web, the concept of web, the World Wide Web, which was actually introduced by Tim Berners-Lee, right? Tim Berners-Lee introduced the concept of web, a World Wide Web in the year 1989. So, what was the importance of that? What was the need of that particular technology? What was the need of that particular innovation of World Wide Web? So before actually this concept, before the emergence of this concept of World Wide Web, the what sharing of information. So if I want to showcase something, if I want to share something to a global audience, so the sharing of information to a global audience was a tedious task, was a very hard task. So if I want to do so, I want to carry this particular data, whole data along with me wherever I go and whoever I want to present. So it was actually a very hectic task. So then comes this WWW, that was the World Wide Web. So it actually caused a great transformation in this world of internet. So after this introduction of World Wide Web, so if I want to showcase something, for example, if I have a product and I want to showcase that product to a global audience, and if I have a company of myself and I want to showcase that company, that this company exists and you can approach this company for this products. So if I want to showcase that particular thing to a global audience, then I can actually put that information as a web page, put that particular information in a web page, and then host that particular web page in a domain. So if I'm posting or hosting that web page in a domain, anyone around the world, anyone around the world at any time can see that particular page, read that particular information at any time. So that was the huge revolution that World Wide Web introduced that time. So it was a great buzz at that time, and it was everyone got with the company or with a product actually bought a .com domain, and they actually hosted their websites, and it was a lot it created a lot trend at that time. So at the beginning, this particular web pages, is not like that we see nowadays. So nowadays we see so much interactive and interesting and attractive web pages, right? So, but at the beginning of this introduction of web, it was not like that. So the web pages at that time consist of only some a list of information and set of hyperlinks. So we can read that information and we can use that hyperlinks to go to some other web pages. We can't interact with this web page. So I will show you the web page actually created by Tim Berners-Lee himself. So this is a web page actually created by Tim Berners-Lee. So this is a set of instructions. We can read instructions from this web page, and actually there are a set of hyperlinks present in this web page, and clicking on these hyperlinks, we can go to that particular pages. So that was actually the web page at the beginning time. So here I can see some scratches happening on the screen. So if you are doing it accidentally, can you please remove it? Okay. So anyway. Okay. So that was the web page. That was a type of web page that we can see in that we can see at the time of introduction of this concept of web. Okay. So we call the a generation, that era of web, as static web, where we can't make any interaction. We can't provide any content to that particular websites or web pages. We can just read the information from present in that page. We can just go from one page to another. That is all. So after that, huge development happened in this web world, and after that, the era of Web 2 evolved. So in this Web 2 era, that actually we are seeing now and from few years back. So in this Web 2 era, what is happening is we can actually interact with this particular application in this Web 2 era. So there comes the generation of YouTubers, bloggers, etc. So they can actually share their content. They can actually create their content and share it in this application. So this application became little more interactive, right? So we can share our content, we can share our data, we can share our photos, we can share our videos. It is actually visible to the whole world through these applications. So people were building their social life with this type of application. So anyway, so that was a huge transformation itself in internet. There was a huge increasing interest in this type of Web 2 based application. So with this type of increasing interest in the Web 2 based application, uh, uh, we are hearing the reports of data breaches, censorship, etc. So why the issues actually happen? The issue of data breach, censorship, all these issues. Why this happen? These issues are mainly due to the centralization of power in this type of Web 2 application, mainly due to the centralization of power in this Web 2 application. So whatever data we are sharing, we are providing to this Web 2 application, they are actually stored, they are actually maintained and stored in their server, in their central servers, right? So they have the complete access towards the data present in this type of application. So that is the case with what a Web 2 based application. And also what we can see, what we should see through their application, they are also they are actually they are actually controlling what we have to see through this application. So who all can see that particular application, who can access that particular application, everything is actually controlled by this type of application. This actually arises due to this centralization of power in the case of Web 2 based applications. So after a few years, now the Web 3 era is happening. So Web 3 era, we can call it as a semantic web or intelligent web, etc. it is a combination of loads of technologies. So the applications present in this Web3 can actually understand us, understand our questions with the tone we can ask them as we ask to our teacher or our friend. So they can understand what we ask, and they will answer to us like the question like we need, right. So that is the case with Web3 based application. So there are a lot of technologies used in this Web3 based application like AI, ML, etc. So our focus, so we have talked about the issue present in Web2 based application, right? The centralization issue. So Web3 actually came to wipe out this centralization issue. So, according to the great computer scientist Gavin Wood, so Gavin Wood actually introduced a new technology to wipe out this centralization. So, in order to have decentralization in the Web3 based application, so we can introduce a new technology. So we can use a new technology called blockchain to to actually eliminate this centralization, to introduce this decentralization concept. So what is this blockchain? It is a very naive technology. So what is this blockchain? So have anyone got any idea about this blockchain? So if you want to share, you can share. Otherwise, I can go with the topic. So we can achieve this decentralization using the technology blockchain. Okay, so before going to this blockchain concept, before going to this blockchain concept, let's I want to take you back a few years back in 2008. So in 2008 was an year of financial crisis. It was an year of financial crisis. So everyone around the world, every nook and corner around the world was affected by this financial crisis. So all the field of industry, maybe it is IT, maybe it is business, maybe it is government, maybe it is bank. Everyone was affected by this financial crisis. But the most affected was the common man, who was completely darked out by what is happening in this crisis period, what is happening with the money, why they are affected more by this crisis. So they actually kind of lost their trust on this central financial system. So maybe as a result of that, a group of people or maybe one people came with a pseudo anonymous name called Satoshi Nakamoto. And this pseudo anonymous name, Satoshi Nakamoto, actually proposed a white paper in the name called Bitcoin. Bitcoin, a peer-to-peer electronic cash system. So he introduced in that particular white paper, he actually want to introduce a decentralized type of financial system. So that was the summary on this particular white paper, Bitcoin white paper. So from this particular term, the Bitcoin peer-to-peer electronic cash system, from the peer-to-peer term itself, we can summarize like there exists a network, and there exists a peer-to-peer something between this network, right? We can assume that from this particular peer-to-peer concept. So yes, it was a network. It is a network. Bitcoin is a network of peers, of systems, of nodes that is distributed around the world. Okay, anyway, we'll come to it. Okay, Satoshi Nakamoto actually published this white paper in the year 2008. So after 2008, in 2009, Satoshi Nakamoto actually launches this Bitcoin network. He launches this Bitcoin network. Okay, so this Bitcoin, the peers, the connection between the peers, he established a network in 2009. And there is a currency in this particular network. It is actually a digital thing, right? It is nothing that physically exists. So there is a currency in this particular network called Bitcoin. That currency, we call it as a Bitcoin. It doesn't have a physical existence. It only exists in this particular blockchain network, this particular network, Bitcoin network. Okay. So he introduced the concept of Bitcoin. He introduced the currency called Bitcoin. And using this Bitcoin network, he introduced a decentralized financial system. So, okay, we'll come to it in deep. And after that, the Bitcoin network actually was growing silently. Okay, it was growing silently. And in the year 2010, the first trading actually happened in this Bitcoin network. So, what was the first trade? A man named Laszlo actually bought two pizzas with his Bitcoin. Actually, he bought two pizza for 10,000 Bitcoin. So I'm sorry for him now. Actually, as of now, one Bitcoin cost around 83 lakhs or something. So at the time of 2010, then when it doesn't have got that much value, this man Laszlo actually bought two pizzas for 10,000 Bitcoins. So that was the main point was that it was the first trade actually happened in the Bitcoin network. So after this first trade, actually, people began to use this particular digital currency, Bitcoin. Okay, a lot of trade actually happened after this particular period. And this particular Bitcoin network was growing and growing. It actually grown to a stage that, according to 2023's report, the annual electricity consumption of this particular Bitcoin network is equivalent to the annual consumption of Netherlands city. So the network actually grown to that extent. Okay. So that was the life cycle of this. That was the journey of this particular Bitcoin network. So now you may got a lot of confusion, right? So how with the help of network we can actually decentralize the financial system? How this transfer of money actually happen in this particular thing? So a lot of questions may occur in your mind, right? So we can we can solve all these questions, all your doubt with the help of an example. So let's take two people, Aradi and Pranav. I'm taking two people, Aradi and Pranav, to friends. So Aradi want to transfer one Bitcoin to Pranav. So here is a scenario. Aradi want to transfer one Bitcoin to Pranav. So in order to transfer one Bitcoin to Pranav, so these people, Aradi and Pranav, want to transfer Bitcoin, not a, physical currency of their state or country or something. So they actually want to transfer a Bitcoin, right? So in order to transfer a Bitcoin, so in order to transfer the data to a Bitcoin network, what you can actually what to be you need to be the part of that Bitcoin network. So like if you want to what deposit your money into a bank or transfer some money using a bank, you need to be part of that bank by starting an account on the bank, right? So if you want to transfer a Bitcoin, you need to be the part of a Bitcoin. So you need to so how can you be the part of Bitcoin network? You need to start an account on this Bitcoin network. You need to possess a Bitcoin address. So can use any means. You can create a Bitcoin address. You can use a wallet to create your Bitcoin address. So here Aradi and Pranav actually possess Bitcoin address. So Aradi want to transfer what one Bitcoin to Pranav. So Aradi want to transfer one Bitcoin to Pranav. So Aradi, in order to transfer one Bitcoin to Pranav, Aradi need to communicate with any of the nodes in this particular network. So as you can see, this is a Bitcoin network. So these are the nodes. So these computers or the CPU like thing, server like thing you are seeing is the nodes present in the Bitcoin network, which is distributed around the world. This particular network is actually distributed around the world. So uh, around around 10,000 active nodes are actually present in Bitcoin. So it may vary. So some active nodes around 10 to 20,000 nodes are present in this Bitcoin network. So these nodes are actually distributed around the world. So in order for Arathi to transfer a Bitcoin, he need to send that particular transaction. Like I want to transfer this one Bitcoin to this particular party. That request. So anyone want to talk? Anyone want to have question? Okay. So if Arathi want to transfer that Bitcoin, she need to communicate with any of the node present in this particular network. Any one of the node present in this particular network. Okay. So here Arathi is communicating with this node, this particular node. So Arathi is sending transaction like she want to transfer one Bitcoin to Pranav, that particular request to this node in the Bitcoin network, this particular node in the Bitcoin network. So what happens then when this particular node receives this request? So this node will verify the request. They will verify the transaction, whether Arathi is Arathi holds the account, this signer is a valid account, or Arathi holds that particular balance. Everything, this to address is a valid address. Everything, the particular transaction is verified by this particular node. And along with verifying this transaction, it will, sorry. Along with verifying this particular transaction, it will send that particular transaction to all the nodes present in this particular Bitcoin network. So is it clear? So along with verifying that particular transaction, the transaction is sent to all the nodes present in the Bitcoin network. So now the transaction is actually communicated between Arathi and this particular node. Now, as of now, this transaction is present in all the nodes in the network. So it is not present in this particular node. It is actually present in all the nodes in the network. So that transaction is actually verified by all the nodes in the network. So this Bitcoin, this particular transaction is verified and verified, and it is actually stored in a temporary storage on these nodes called mempool. After the verification, this transaction is actually stored in a temporary storage. We call the temporary storage as mempool of the node. And after getting a list of transaction, all these nodes present in this particular Bitcoin network will take a list of transaction, will take some transaction, and all the nodes will form a block. I will repeat, all the nodes in this particular network will form a block with set of transactions present in their mempool. Okay, so all the nodes will create a block. So now every nodes in this particular network have a block, right? So now what will happen? So does everyone will add this block to the blockchain? So it won't happen like that, right? Only one block can be added to the blockchain. So so now we have to select who will add this block to the blockchain. So how we can select the who is the leader or who is the winner who can add the block to the blockchain? So here there is a consensus mechanism. No central authority is actually selecting a single person for adding block to the blockchain. There is no central authority or higher power that will assign, okay, you create the block and you add the block to the blockchain. There is no one like that in this particular network. Here there is an there here we have to make an agreement, right, to who should add the block to the blockchain. So now the agreement is actually made using a consensus mechanism. So for this Bitcoin network, we have a consensus mechanism. So in the case of Bitcoin network, the consensus mechanism using is proof of work consensus mechanism. So in the proof of work consensus mechanism, we are actually solving a puzzle, a cryptographic puzzle. So in the case of proof of work consensus mechanism, we are actually uh, solving a puzzle. Okay. So someone asked to repeat. So I will quickly repeat the whole process one more time. Here, there are two people, Arati and Pranav. So I can say one thing. So you can actually unmute your mic and ask. It will be helpful. So I have to move on chat. So that's why I'm taking time to reply for your answers to your questions. So you can just unmute and ask. Okay.
Yeah,
So,
I given the
uh,
unmute option to the all the students. They can go
okay.
ahead and ask question.
Okay. So, so anyway, I'm just repeating one more time. So here, Aradi and Pranav are two people, and Aradi want to transfer one Bitcoin to Pranav. Okay. So in order to transfer one Bitcoin or any transaction in a Bitcoin network, they want to possess an account like a bank, right? So in order to transfer in a Bitcoin network, uh, this particular person need to possess an account, Bitcoin address. So here Aradi and Pranav holds a Bitcoin address. So Aradi now, in order to transfer one Bitcoin to this particular person, Pranav, need to communicate with any of the nodes present in this Bitcoin network. So this is a Bitcoin network. There are thousands or 10,000s of nodes actually present in this Bitcoin network. And all these network, this is a peer-to-peer network. All the nodes in this particular network can communicate with each other. And in order to send a transaction to this particular network, Arati need to communicate with any of these nodes, any one of this 10,000 or 20,000 nodes present in this particular network. So now Arati is actually communicating with this particular node in the network, that I want to do this particular transaction. And and this node receives this particular request from Aradi, and the node verify this transaction. Okay, node actually verifies this transaction, and along the verification of this transaction, this particular node actually send this transaction to all the nodes present in the network. So along the verification of this transaction, this particular node send the transaction to all the nodes present in this Bitcoin network. So what happened next? All the nodes in this network will verify the transaction. And after verification, this particular transaction is actually stored in a temporary storage. We call this temporary storage as mempool. Okay, mempool. We call it as a mempool. So now all the nodes in this particular Bitcoin network holds this particular transaction in their mempool. Okay. So after verification of this transaction, after a particular time, all the nodes in the network will select a set of transaction from their mempool and form a block. Okay, all the nodes here, I repeat, not only one node, all the nodes in the network will create a block with a set of transaction present in their in their mempool. So block is actually a set of transactions. So that can include Aradi's transaction also, right? So every node in the network will form a block. Now the question is, who will add block to the blockchain? So here there is no central authority to decide. Okay, you go and add the block to the blockchain, or otherwise you only verify the transaction and add the block to the blockchain. So no, there is no central authority like that. Everyone is equally responsible for verification, and everyone is equally privileged for adding block to the blockchain. So what happens? Now we need something to decide who will add the block to the blockchain, right? So here we need an agreement. So in the case of Bitcoin network, we have a consensus mechanism. So in the case of Bitcoin, the consensus mechanism is proof of work consensus mechanism. So here the proof of work consensus mechanism is actually actually done. So in this proof of work consensus mechanism, a cryptographic puzzle is actually given to all these nodes in the network. So all these nodes in the network have to solve a cryptographic puzzle. So whoever wins in this particular puzzle will be responsible for adding the block to the blockchain. Okay, whoever solves this cryptographic puzzle successfully is responsible for adding its block to the blockchain. So here this particular node had won have solved the cryptographic puzzle, and now this node is responsible for adding block to the blockchain. So after knowing that he is the winner, he do what? He will send send the block created by that particular node to all other nodes in the network. So after knowing that he is the winner, he will send his block to all the other nodes in the network. So what will happen after that? It will directly does it will directly added to the blockchain? No. Here the blocks are verified. All the nodes will verify the blocks. All the nodes will verify the blocks, and after verification of these blocks only, they will add the block to the blockchain. So they will add that particular block to the blockchain. Okay, after verification, all the blocks are there. The block is present in all the nodes. That particular block created by the winner node is actually present in all the nodes in the network, and all these nodes will verify that particular block, and after verification, that particular block is added to the blockchain. Okay. So now that block containing Aradi's transaction, let's imagine it contain Aradi's transaction. That block that contain Aradi's transaction is added to the chain of blocks. Okay, so chain of blocks, or we can call it as this blockchain. So once that particular block containing Aradi's transaction is part of this blockchain, the real one Bitcoin gets transferred from Aradi to Pranav. So after adding the block to the blockchain only, the actual money, the Bitcoin, get transferred from Aradi to Pranav. So this is the case with the transaction happening in a particular Bitcoin network. So anyone want to ask something? Okay, I think so. If you want to ask, you can ask. Okay. So so this is how a transaction actually happening in this particular Bitcoin network. So you may have little more confusions now. So what is this? How this particular thing become a decentralized financial system, and how these transactions are auditable, how these transactions are visible to everyone, like that, right? So actually, this blockchain of blocks. So a group of transaction is selected and is created as a block and is added to the blockchain. I have already told you, right? A group of transactions are selected and a block is formed and a block is added to the blockchain, right? So this blockchain, you can imagine now, right? This blockchain is a list of transaction. So you can consider this blockchain as a ledger book. Okay, you can consider this blockchain as a ledger book. So in ledger book, you keep all these transactions, right? So this blockchain, this particular blockchain, one part of blockchain is the ledger book. So this this blockchain, you can consider it as a ledger book. We can call it as a ledger book. So ledger book having a list of transaction, and where each page in the ledger book uh, can be considered as a block. Each block can be considered as a page in the ledger book. So each page contains what? A list of transactions, right? So likewise, each block contain a list of transaction. Each block contain a list of transaction. Coming to this block contains a list of transaction. Coming to the next block, this green one, this block also contain a list of transaction. Coming to the next purple one, this block also contains a list of transaction. So this is actually considered as a ledger book with a list of transaction, with each page contain a list of transaction. And so this is a Bitcoin network. And this Bitcoin network is actually distributed around the world.
4 तारीख का लेक्चर कैंसिल, ठीक है? लाइव सेशन है 8 से 9:30 आना.
So if you are not talking to me, can you mute? So if you are this particular Bitcoin network is actually distributed around the world, and it contains a ledger mechanism. So what is the specialty of this ledger mechanism? All the transactions are actually kept as a block in this particular ledger. Each block is a set of transaction, and this particular ledger book, this set of transaction, this chain of block is actually not kept by any one block, one node. It is actually kept by all the nodes present in this particular network. It is this particular ledger book or the chain of blocks. It is actually kept by all the nodes present in this, all the nodes present in this particular network. Okay, so and this particular ledger book, the same copy of, and one more specialty is that the same copy of ledger book is present in all nodes in the network. So this contain a ledger book, the same copy of this particular transaction, list of transaction is present in this node. The same copy of list of transaction is present in this node. Same copy is present in this node. Likewise, every node in this particular network contains same copy of the Bitcoin transactions. So that is the specialty of this type of network. It is the data is actually distributed. Data is actually not stored in any one or two nodes. It is actually present in all the nodes present in this particular network. The data means the ledger. Ledger is actually present in all nodes present in this particular network. And also there is no central authority to control this particular transaction. There is no one to control that. So Aradi can't send this transaction now. Aradi have you please schedule this transaction to some other day. No, there won't be any person to do like that, like things. So there is no central authority to control the working of this whole transaction, working of this whole network. All the transactions are verified by all the nodes present in the network, and all the nodes are responsible for creating the block. And the winner node is not actually selected by a higher authority or something. It is actually based on a cryptographic puzzle. Whoever solves this cryptographic puzzle is responsible for adding their block to the blockchain. So there is no central authority thing in this particular Bitcoin network. Okay, so I am talking about this Bitcoin network, right? So the underlying technology. So if we are taking a single cover from this Bitcoin network or a hood, if we open the hood in this particular Bitcoin network, it is the underlying technology here is blockchain. So Bitcoin actually uses the blockchain technology in its network. So actually, Bitcoin actually came give a light or flash the light towards this blockchain technology. So all the things I have said is actually the underlying features of blockchain technology. So what I have said, it is a distributed network. There is a peer-to-peer communication occur between this network, and the data present in this particular network is actually distributed around this particular network, and it is actually a distributed ledger technology. A ledger of transaction is actually maintained by all nodes present in this particular network. It is not maintained by a single or two or three nodes. This particular ledger is actually kept by all nodes in this particular network. So it is a blockchain is a blockchain. We can consider it as a blockchain. We can call consider it as a distributed ledger technology. So it is a distributed ledger technology. The data present in this particular particular network is actually distributed around the node. So we can consider it as a distributed ledger technology. So so I have already told you the underlying technology behind this Bitcoin network is blockchain. So all the features I have told you is actually the feature came with the blockchain technology. Okay. So here considering the ledger, I've already told you the ledger. We can consider this as a ledger, and each block can be considered as a block. Each page in the ledger, each block can be considered as a page in the ledger book. So here is a data present in a block, a pictorial representation, or there are some sites where we can see where user can see the transactions happening in a Bitcoin network. I will show you the site. So this is the data present in a block in the blockchain. There are a list of transactions with lot of informations regarding this transaction, like who sent this transaction, to whom the transaction has been sent, and what is the value being transferred through this transaction. All these things is actually noted in this transaction. So a single block contains a list of transaction, and the ledger book is actually a chain of blocks. This is actually a chain of blocks. So each block contains a list of transaction, and likewise it is a chain of blocks, each block containing a list of transactions. Okay. So coming to blockchain, so I have already told you the underlying technology behind this blockchain is so Bitcoin network is blockchain. So revising these features, I have already told you in Bitcoin network, a blockchain is actually, it is a distributed ledger technology. That means I have already told you the data or the information regarding the transaction is not present in a single node in the network. It is actually present in all the nodes, each and every node present in that particular network. So it is a distributed blockchain, is actually a distributed ledger technology. Okay. And it is one feature. It is only one feature of blockchain. It actually maintains a ledger. It keeps the data distributed uh, around the nodes in the network. And another feature is decentralized. in the case of Bitcoin, you have seen, right? There is no central authority to decide when the transaction should occur. We have to place this transaction to some other time. Does we can cancel this transaction, or like who will be responsible for verifying the transaction? No, there is no central authority for doing all these things. All the nodes in the network is responsible for verifying and adding the transaction to the ledger. Everyone, each and single node is responsible for verifying and adding the particular transaction to blockchain or ledger. And there is no central authority deciding who is responsible, who is the winner, whose block is to be added. Right? There is no central authority for controlling anything. So it is a decentralized network. Each and every participant or nodes in this particular network is responsible for managing this network, controlling this network. Okay. So next feature of blockchain network is distributed. I've already told you, data here is distributed. It is not in the hands of a single node. It is not in the hands of 2 or 3 nodes. It is in the hands of every node in the network. Right. Each and every node, it may contain 20,000 nodes. Each 20,000 nodes in the network possess this data. It is actually distributed. Data is actually distributed among the network. So these features I have discussed, that it is a blockchain is a decentralized ledger technology. It is a distributed network with no central authority. Yes, you can ask.
Ma'am, can you please explain ledger again?
Yes. So one of the feature of this blockchain technology is the ledger technology. So the main feature of this ledger technology is that this particular ledger is distributed around all the nodes in this particular network. Okay, all the nodes in the network is responsible for maintaining the data, maintaining the transactions happening in this particular network. The transactions happened from 2009 when this Bitcoin network actually came till now, till this second, is actually present in all the nodes in this particular Bitcoin network. Right. All the transactions from the beginning till now, till this time, is actually marked in this ledger, that is present, that is distributed among all the nodes in the network. And now, what is in this ledger? What is present in this ledger? So in this ledger is actually we call this blocks. We call the term blocks. Each block contain a list of transactions. So a list of transactions. So I have already told you, when a transaction came to the node, it is added to their mempool, right? It is verified and then added to the mempool. And from the mempool, a list of transaction is taken and a block is formed. So block is what? A list of transaction. So a block contains a list of transaction, and the whole block of chains, this whole block of chain form a ledger book, and each block contains a chain of transaction. Let's imagine this is the first block actually created at the beginning of Bitcoin network. Let's imagine this black one. Okay. So this black one contained the list of transactions happened from the beginning, at the time when Bitcoin network was formed. And after the one block contains a limit, how much there is a limit for number of transactions that can be added to that particular block. When it reached the limit, the remaining transactions are actually stored in the next block, and the remaining transactions are actually stored in the next block. Likewise, we started our ledger book from the starting of the book. We write the transactions in a single page, And when one page is over, we go to the next page and begin to write the transaction. Likewise, each page can be considered as a block. And each block contains a list of transactions like this. Each page contain a list of transaction, or each block in the Bitcoin network contain a list of transactions. And this list of transactions, this is a chain of blocks. This is the block number. Let's imagine it as block number 799491. This is the block 799411. And this is the block 492. And this is the block 493. All these block contains a list of transactions. So this is a ledger. It contains all the transactions happened till now. If we take all the blocks from the first block, we call the first block in a blockchain as Genesis block. If we are taking from the Genesis block till now, information from the Genesis block till now, till this time, if we are considering all the blocks, we will get all the transactions happened from the time the block Bitcoin was created till this time. So that is the ledger concept. All the transactions are actually maintained in the ledger, and the specialty of the ledger is what? It is actually not maintained in a single point, right? Like in a database. In the case of normal applications, it is actually maintained. Ledgers are actually maintained in a database, which may be stored in 1 or 2 or 3 places. So this is not like that. It is actually distributed around the whole network. If as of now, number of active nodes is around 10,000 or something. This 10,000 nodes actually process this particular ledger. The data is actually distributed around this particular network. So that is the case with ledger. So I think it is clear. So if you have any specific doubt, you can ask.
Ma'am, is this because of this decentralized system, blockchain is not regulated, like Bitcoin system is not regulated in many areas? This is because this decentralized system, or any other reasons are there?
So it is according to the government present in that particular state. They have to actually accept that particular transaction for trading. The regulations is actually came to scene when the question of trading, of course, actual trading. If I want to buy something from a shop, and if I can I buy something from the shop? Can I buy rice from the shop with a Bitcoin? So then the question of regulation actually occur, right? So that regulation thing is actually with the power that concerned with the government, or in the case of India, it is the RBI or the government to decide whether that particular country have to regulate it. That means they have to consider this Bitcoin as a currency, like their their state currency, their local currency. So the regulation means actually came into question when it comes to trading thing. If I want to buy something with that particular money, so if I want to buy something something in Bitcoin, then it should be then the country should be regulated. Country should consider that Bitcoin as a currency. So that is the question of regulation. It is not. It doesn't have to deal with this decentralization thing. It is not because of that. The country have to regulate that currency. That is because there is a question of regulation in the Bitcoin. The country, in the case of India doesn't consider this cryptocurrency for actual trading. So that is why we call it as it is not regulated in India. That is the case.
Thank you, ma'am.
Okay. Now, okay, I think it's clear. And so I have cleared the features like ledger. It's a ledger technology. It is a decentralized ledger, and decentralized thing. No central authority is there, and it is distributed. like all these things we have cleared. There is one more thing, one more feature of blockchain, very important feature. Blockchain is immutable. We can't make any change or making any change to the transaction present in the blockchain network is feasible, practically infeasible. Okay, we can't make any change to the transactions present in the blockchain. So it is practically infeasible to make any changes to the transactions present in the blockchain. So I've already told you this ledger book or the blockchain consists of a list of transactions. So if any person if I want to make a change on the transaction present in the block number 492, it is actually practically infeasible to do that. So that is why we call blockchain as immutable. We can't tamper the data present in the blockchain network. So we will see what is this? What is this immutability? What is this? What is this infeasible? What makes it infeasible to make any changes to this transaction? So that is what we are going to see next. Okay. So I have already told you there are in blockchain, one of the feature of blockchain is it kept ledger in the form of blocks. It keep the ledger in the form of blocks. And there exists a link between the blocks. That is why we call it as a blockchain. There is a chain, it is a chain of blocks. In the case of chain, there is a link between each block of chain, right? So here also there exists a link between the blocks in this blockchain. So what is this link?
देखो तुम्हें दिखाता हूँ तुम्हें समझ में आ जाएगा ना बेटा
So if you are not asking question, can you mute your mic? Yes, thank you. There exists a link between the blocks in the blockchain. It is not like we form a block, add to the blockchain. It's not like that. There exists a link between the blocks in the blockchain. So what is the link? That's what I'm going to tell you. What is the link in this case of a blockchain? So this is a block. So I'm considering a block. This is a pictorial representation of the data present inside a block. So a block mainly consists of a header part and body part. So what we have seen in this figure is the body part, a list of transactions. Oh, like right, the list of transactions. So this is the body part of a block in the blockchain. So coming to the header part, there is a header part. Coming to the header part, there are a list of information present in the header part. So it includes the timestamp, the time in which the block has been created in the UTS timestamp. So this is a time when which the block is added to the blockchain. Okay, that is the timestamp. And there is another thing called nonce. Nonce is actually related to the solving of this cryptographic puzzle thing. So it is actually used for solving this cryptographic puzzle. And then came next information in this header is root hash. So what is this root hash? Root hash is a very important thing. Root hash is actually a hash value. So it is actually calculated using a specific data structure called Merkle tree. So we use Merkle tree here. So I just go through this particular thing. If you are not a computer science student, just you can just omit it. Okay, it is not that important. So we use a data structure called Merkle tree, and in this Merkle tree, it is a tree-like structure, and in the leaves we store the transactions. The transactions present in this particular block is actually stored in this tree-like structure. the hash of these blocks are actually, hash of these transactions are actually stored in this tree-like structure. And their root, we calculate the root after storing the hash in the leaf of this particular tree. We calculate a hash value using the transactions in the block. So that hash value present in the root of the tree is called as the root hash. For simple, you can just understand like this. This root hash is a representation of all the transactions present in that particular block. It is a representation of all the transactions present in a particular block. So what is the specialty with this root hash? If we try to change any of this particular transaction, then what will change? The root hash will change. Okay, just understand that. The root hash is the representation of all the transactions present in the particular block. Okay, and if anyone try to make a change on any one of the transaction, then who will be affected? The root hash will be affected. The root hash will change. That is the case with root hash. And there is one more information called previous hash. So what is this previous hash? The previous hash is the hash value, is the block hash of the previous block. So this is the information I'm talking about this block. Anyway, all the block contains all this information. Anyway, I'm talking about this block. And previous hash means hash of this block. So what is the hash of this block? What is meant by hash of a block? Hash of a block means the hash of the values present in the header. We calculate a hash using the values present in the header. That means mainly timestamp, root hash, nonce, and the previous hash. So with all this information, we create a hash value, and that is called as the block hash. So this block contains a block hash. This block contains a block hash. This block have a block hash. Likewise, each block have a block hash, which is actually calculated from these values, that like timestamp, root hash, nonce, previous hash. Okay. Now there is one more twist. The hash of this block is stored in this particular block. The hash of this first block is actually stored in the second block called previous hash value. In the previous hash value, the hash of the previous block is stored. So that actually acts as the link. The hash of the previous block is actually stored in every next block. Like the hash of this block, first block is stored in the next block. Hash of the second block is stored in the third block. Hash of this third block is stored in the fourth block. Likewise, it will repeat. Each block will store the hash value of the previous block. Okay, so in the case of this block, it actually store the hash value of this particular block. Okay, is it clear? So this are the fields on this header, block header. And using the values present in block header, a hash of the block is created. Okay, so this first block have a block header, and using that block values present in this block header, the block hash is calculated. That block hash is actually stored in the next block, and using all the values, including the previous hash, the header of this second block is calculated, and a block hash of second block is calculated, and that hash is actually stored in the next block. And in the next block, next block also, using the previous hash value, block hash value, and other values present in the header, hash value is calculated. Likewise, the hash value of the previous block is stored in the next block. So there, the previous hash actually act as a previous link. Like in the linked list, if you have studied about linked list, there is a link. There is a link which is an address of the next block, right? Likewise, here previous hash actually act as a link towards the previous block. So previous hash actually act as a link towards the previous block. So that is the case with the chain, block that we call as a blockchain. So it is a chain of block. There is a link between this chain. So what is the link? The previous hash actually act as the link between the chain. So what is the importance of the storing of this previous block or maintaining this chain? So what is the importance of that? And what is the case with immutability with all these things? What is the connection of immutability with all these things? So that is what I'm going to say next. So I think it is clear with everyone. If you have any doubts, you can ask. So now coming to the immutability property. What is the immutability property had to do with this chain of blocks concept, the previous hash concept, the root hash concept, what it has to do with that? So that I want to show you in using this diagram. So this is the first diagram. There is a chain of blocks. There is a blockchain there is a ledgers. And 9 in the first block, the hash value of the first block is it is actually a hash value or a hexadecimal value combination of numbers and digits. So the hash value of or the block hash of or the hash of the block first block is 9E76, etc. And this block hash is actually stored as the previous block hash of the whole previous block hash value of the second block. You can see, right? 9E76 is actually stored as the previous block hash value on the second block. And this previous block hash value along with other values in the header is actually used to calculate the hash of this block. Okay, this 56TY. The hash of this block is actually stored as the previous block hash of the third block. You can see, right? 56TY. And using this previous hash value along with other block headers, the hash of this block is calculated, that is 0D87. And this is actually stored as the previous hash value on the next block, likewise. So this is how actual blockchain happens. So if any changes happening on this previous hash value or in the root hash, I have already told you there is a thing called root hash, that hash of all the transactions present in blockchain, right? Or any change occur, any small change occur in this particular header values will cause a change in hash value change in this part, the hash of this block, hash of the block will change. So if you try to make any change in any of these value, maybe it is a previous hash, maybe it is a root hash, maybe it is a timestamp, maybe it is a nodes, any change occur if occurring in this particular field, any small change will cause a huge change in the hash value. The block hash value will change. So if you're trying to make any change in any of the header values, the hash value of the block will change. So if that thing happens, if someone is trying to change a transaction in the third block, okay, if someone is trying to make the transaction in the third block, okay, so everything everything happened like I explained before. The first block hash is 9676. It is stored as the previous hash in the second block, and the hash of the second block is 560Y, which is stored as the hash of the third block. And the hash of the third block was actually 0D87. So someone actually tried to make some changes on a transaction present in the third block. So the third block if someone is trying to make any changes in the transactions present in that particular block, the root hash will change. So I've already told you, any small change in any of these fields will cause in change of hash value of that particular block. If the root hash will change, the hash value of this particular block will change. So if someone is trying to make any change in that particular transaction, will cause transaction or any value present in that particular header, the hash of the block will change. So the 0D87 was the hash of the block. It is now changed to 3B21. So now the chain had breaked, right? In the next block, the previous hash value is stored as 0D87, but the block hash of the previous block is 3B21. The chain has broke, right? So this will cause, if anyone try to make any change in the transaction, this will cause the breaking up of the chain, and this particular change in the data, in the hash values, any change can be noted by that particular node or anyone, and can detect that particular node can get the correct transaction from other nodes, because all these transactions are present in all the nodes present same copy of transaction. So if particular node detects that something happened in the copy processed by them, if node A actually detects that, oh, something is wrong with the copy of transactions maintained by me, so then if I am not malicious, I can just go to some nearby node, maybe node B, and request for the ledger, copy of ledger. It will send the ledger and I can keep that as my ledger. Since everyone keep the same copy of ledger, I can correct my ledger. It is that easy to correct my ledger. So if I am deliberately trying to do that, I will be penalized if someone else in the network detected. So it is practically infeasible to do so. So if I am trying to do any transaction change or change in the transaction in a particular in this particular blockchain network, I am not going to change this transaction in the if I am I am working in this particular node and I want to change do some malpractice on a transaction. I am not going to change in in the transaction present in my blockchain or my ledger. I need to change that thing in all the 10,000 or 20,000 nodes present in this particular network, which is actually practically impossible. We can see it as practically impossible itself. So because of that fact, we call the blockchain network as immutable. No one can make any change in this blockchain network. So that is the case with immutability. So that is the most important features of a blockchain. So blockchain is a distributed ledger technology. It is completely decentralized. There is no central authority to maintain this particular ledger, and it is immutable. No one can make any change in the transaction that is marked in blockchain. So that is the case with immutability, and so that is the immutability factor. So the hash of the first chain actually act as a link between the blocks. Hash 0 act as the link between hash 0 and this block, and block 1 and block 2. Hash 1 act as a link between block 1 and block 2. Likewise, it will repeat. So you can see, right? hash 0, there is a link, a hash. The hash value of the previous block is actually acting as the link between these two nearby blocks. Hash 0 is acting as the link between block 0 and block 1. Hash 1 is acting as the link between block 1 and block 2. Likewise, the link exists. If I try to make any changes to the block in a blockchain, its hash value will change and this particular chain will break, which is easy to detect in the case of a blockchain. So I've already told you, I will show you is where you can explore this particular network, Bitcoin network, right? So this is a place, we call it as Block Explorer. So there are so many explorers. This is Block Explorer where you can explore a network. It actually give a dashboard where where a normal user can actually see the transaction, understand the transactions happening in a network. So this is a Bitcoin network. You can see the current value of this Bitcoin network. These are the blocks actually. This is the latest block actually formed in the Bitcoin network. It actually formed 15 minutes ago. So these are the blocks present in the blockchain. So you can see all the blocks present in the blockchain. So I'm taking any, you can take any block. So I'm taking the information of this block. So while taking the information of this block, it is actually a list of transaction. Block consists of a list of transaction. It actually contains 2,463 transactions. Understand? It actually contains 2,463 transactions. And all these transactions, this Merkle root is the what? Is the representation of all these 2,000 transactions present in the block. If you try to make any change in the transactions present in this block, the Merkle root value will change, and what will change? The block hash will change. The block hash value will change. So, so you can actually view the transactions in this block, and if you want, you can actually go to each transaction. So this is one of the transaction. You can actually view from whom this particular Bitcoin is transferred into which address, what all transactions happened, everything you can see, what time it has happened, everything you can see. So Bitcoin, we can call it as a kind of public network. So public blockchain network. Public blockchain network means anyone can actually go there and audit it, can see what is happening, which block, which transaction, who transferred, at what time, what amount he transferred, everything is transparent in the case of public blockchains.
Ma'am, what is the difference between Bitcoin and cryptocurrency?
So Bitcoin is a cryptocurrency. Bitcoin is the cryptocurrency of this Bitcoin network. So for every blockchain network, there exists a cryptocurrency. So if you are Bitcoin is not only one blockchain network. I think you know about that. So there are so many blockchains like Ethereum, Algorand, Polkadot. So many blockchains are there. So each blockchain possesses their own currency, their own cryptocurrency. So in the case of Bitcoin, it is Bitcoin network, it is Bitcoin. In the case of Ethereum, it is Ether. Like each cryptocurrency, each blockchain network, there is a cryptocurrency. In the case of Bitcoin, it is completely a financial type of currency. For it is completely built for financial transactions. But in the case of other networks, it is not like that. You will in tomorrow's session you will see about other blockchains. So the other programmable blockchain like Ethereum. So in the case of Bitcoin, it is just act as a cryptocurrency. So there is no difference between Bitcoin and cryptocurrency. So every blockchain has a cryptocurrency. In the case of Bitcoin network, Bitcoin is the cryptocurrency. So is it
And
clear?
ma'am, it's in digital form or physical?
Oh, it doesn't exist in physical form. It only exists in digital form. So it doesn't have any physical representation. It only exists in a digital representation. We can only make digital transactions with this Bitcoin.
Hello, ma'am. I have a thought.
What?
Hello.
Yes, I
Yeah,
can hear you.
actually, in year 2355 or 25 somewhere, the last block of the blockchain will be mined.
No, it is not like that. Last Bitcoin will be mined. Last Bitcoin will be mined by that year. Bitcoin has a limited supply. 21 million is the supply of Bitcoin. It is actually for giving a value to that particular currency. The 21 million is the. So anyone unmuted the mic? Can you mute it? So for in the case of Bitcoin, the total supply of Bitcoin is actually what limited. It is 21 million. There is only 21 million Bitcoin in supply. So by 2040 40 something, whole 21 billion Bitcoin will be mined out. So after that, no new Bitcoin will be formed. So you have to, after that, all the transactions, all the trading will be with this 21 million supply. That's all. Blockchain will be there, blockchain will be formed, but no new Bitcoin will be mined out. Okay.
Because the validation of the crypto, like block transaction, is validated by the nodes.
Yeah.
Yeah. If nodes were not running, because the by the miner, like the people who are mining blockchain, like Bitcoin, why they will run miners when they are not getting reward for their mining.
Yeah, I can understand.
If
So
if
if you are worried about if
Hmm,
new Bitcoin is not mined, then why they should
hmm,
mine, right? They should form the blocks,
hmm,
right? Yeah, the thing
hmm,
is that they at the beginning of this Bitcoin network itself, they have calculated like Bitcoin will gain
hmm,
the value, and the
hmm,
on 20 on reaching this 21 million or reaching this particular year. So
hmm,
the miner is not only getting this mining reward, they are also
hmm.
getting this transaction. We are on validating in this transaction, they are also getting this transaction fees, right? Transaction reward also. Mining reward is something they are getting as an extra for
Yeah, yeah,
yeah.
ma'am. I actually accept that. But I'm also a blockchain miner. Like I mine bitcoins. Uh, because like as much as I know about it, like what the transaction value, the reward which we get on the value of validating the transaction is way comparatively less than mining a blockchain.
Yes, yes.
Like if I'm validating it 10,000 transactions on my miner per day, I'm getting somewhere around 0,000 or 403 worth of Bitcoin. Okay. If I'm mining a Bitcoin I'm mining Bitcoin on my miner, ASIC miner, I'm getting somewhere around like 5 to 0.08 to 0.09 0.07 Bitcoin worth a day,
Yeah,
which is comparatively high,
yeah,
like for a day. But maybe if the number of miners has been increased in last 3 4 years, somewhere around 20,000 to 58,000 to 1 lakh miners has been reached entire world right now. Okay, there are so much congested in validating the Bitcoin. So in starting era, the Bitcoin validation may take up to 15 to 20 minutes of time. Now the Bitcoin validation, like a transaction validation, which was happening in less than 1 minute to 30 seconds to 1 minute 55 seconds
Mm.
for a transaction. So like there are so many miners are available right now. Even though there are few bitcoins are left to mine, people were eager to mine those bitcoins too. And they were like so many people are buying crypto miners, and it was like according to the ASIC miners report,
Okay.
the Bitcoin miners is going to reach somewhere around 1,30,000 by the 2026, according to their market share report. So, like,
Okay.
if there are so much crowd in the market, like the comparatively transaction fees is going to be like a transaction validation fee is going to get very less to the who is validating the those blocks and transactions to
Okay.
the
Even
ASIC
even
miners
if
or
the
graphic vendors.
transaction miners are getting increased, and the value of Bitcoin is also increasing, right? If
Yeah, but
the
I.
value now you are getting as a new Bitcoin mined and as a transaction fees, and you are earning something, and after some time you are not getting a new Bitcoin while creating a block, but the transaction fee you are getting is will be equivalent to something that that you get now. The value of Bitcoin will be increased at that particular time. The network will run with it is actually calculated like that. The network can run according to the what with this particular transaction fees, because the
Yeah,
calculation that the
okay.
Bitcoin value won't drop, it will increase. It will increase. It
Mm,
is based on this calculation. The miners can exist, miners will exist in this particular blockchain network
mm,
with this transaction fee. That they
mm,
even with the transaction fees, it is
mm,
profitable for them. It will become profitable for them. So it based on that, and also halving is happening, right? For each in
mm,
each 4 years, halving is happening, and
mm,
the mining is actually halved. The mining reward is actually halved, and
mm.
anyway, it will end some year
Yeah,
20 years after this. So
yeah,
the value of this particular transaction, particular Bitcoin, will be as high the miners can exist without getting
mm.
this miner fees or the new coin base reward. So
Yeah,
it is
actually, but
calculated based on.
there is an issue in it. Like you we can't withdraw the money which we got until we reach certain number of coins or a certain number of blocks we have in our wallet. Like uh, if we are having 0.5 worth of Bitcoin, we have reached that value, then that is the thing. At that time, we can withdraw our Bitcoin which we have mined. Like there will be like some X amount that we need to reach when we are mining. But by validating that, it's not easy to reach that amount as soon as possible.
uh, that thing I'm not clear. So that
Hi Lakshmi, I can add over that statement. Karthikeyan, you have to mix economics into the picture and for example, compare
Mm,
gold market cap against
mm,
Bitcoin, which is very minimal. So
mm,
Bitcoin is a store of value. Bigger companies will
mm,
always do the mining since
mm,
the market value will improve upon time. And
mm,
uh, we won't be able to compete in terms of block hash, to compete with the bigger fishes. So mining will happen, and the economics uh, will flow, but
mm,
uh, with a limited amount of mining gear, we won't be able to reap the rewards. You get my point.
mm.
So
Yes.
I would suggest best way you can initiate yourself into the mining pool and collect
Mm,
collective reward. So in that way, you won't be losing money. Hope I answered your question.
Okay,
Yeah,
thank you.
that got. Thank
Yeah,
you.
thank you. I'm not
That's
an
clear.
economic person. Thank you, Aravind. So why blockchain? So why we are blockchain in this real world? So we only saw Bitcoin. So from the Bitcoin, we see the features of blockchain, right? So blockchain is not something that can only be used in a financial system. It has a lot of capabilities. So we can actually use blockchain other than financial systems. So why we use blockchain in other application? Because blockchain is traceable. So we can trace back to any extent. So if I want to trace back to first transaction I made on the Bitcoin network, I can do that. Or if anyone, not only me, if anyone around the world want to trace back to my address, to want to trace back what transaction I have made on that particular day, anyone can trace back. That is the case with this particular blockchain network. Anyone can trace back to any transactions happened or any address present in that particular blockchain network. And coming to the security, the data present, security is actually, we can say, with the data present in this particular blockchain network. So the data present in this blockchain network is, we have already seen, it is actually distributed. There is no central point failure in this blockchain network. If one of the node actually fails, we can get the data from some other node in the network. It is distributed around the world, right? So data availability is there, data security is there. We have already seen it is immutable. There is no, we can't make any changes to the data present in the blockchain, and is auditable. Anyone around the world can actually see the transactions present in that particular blockchain. You can do it manually, or you can do it through some block explorers. There are so many block explorers, or there are so many other sites where they audit for you. So you can easily go, and if you want to do any audit in that particular network, you can do that. It is completely auditable to anyone around the world, and it is distributed. It has a universal record keeping mechanism, and also there is no middleman. We can avoid the middleman in if we are using blockchain in the real world application. So why we can avoid middleman, we will see in tomorrow's class. So there is a case of programmability. We can introduce a case of programmability in blockchain. So by that, we can actually avoid this middleman thing. By simply saying, we are avoiding the concept of bank by using Bitcoin, right? So the middleman to manage my finance. So here I am directly managing my finance. No one else is managing my finance. There is some network who validates it, and there is no central person who is deciding about my transaction, right? So we can avoid the concept of middleman in the case of blockchain. So Bitcoin have some short note. We can't call it as a short. Bitcoin is built for that. It can only do financial transaction. It's built for that. We can't call it as a short. It is built for that. So we can actually use this blockchain but the underlying technology blockchain is not minimized or not used. It is not something which only be used for financial transaction. It have other capabilities. So the shortcoming with the Bitcoin is that we can't program it. We can't write a program for an application and run it on Bitcoin. So that was the shortcoming with the Bitcoin network, and it was actually eliminated by a new programmable public blockchain called Ethereum. So Ethereum is a public blockchain. It's a programmable public blockchain where we can run application. Like Bitcoin only deals with financial transaction, but in the case of Ethereum, we can run applications on this blockchain network, like our Facebook, like our bank application, GPay. So any applications we can run in the Ethereum network. So now we are going to the potential. So you will see, you may have so many doubts with this Ethereum. It is a completely vast topic. Vast topic. So you will see this about this topic tomorrow. There is a session arranged tomorrow. You will see about Ethereum on tomorrow's session. So coming to the potential use cases where we can use this blockchain. So that is next we are going to see. So you can use this blockchain network in several domains. In several domains, you can use this blockchain network. Since it is blockchain have several features, right? It keeps a distributed ledger. It is distributed. It is auditable by anyone. It is traceable. It is immutable. There are so many features of this for this blockchain network. So it, of course, because of these features, we can use this blockchain network to different domains. So one of this domain is education itself. So education is a very important domain, right? So in the case of, in the education world, there are so many cases of fraudulent certificates available, right? So many people are going abroad with fraudulent certificates they got from this university, that university, like that. And all these persons, all these institutions that receive this certificate doesn't have any means to validate whether it is a counterfeit certificate, whether it is a valid certificate or not, whether he actually studied that course or not, right? So we can actually do that, validate a certification using blockchain. So universities can actually issue the student certificate with an ID in a blockchain, can, and anyone around the world, since it is traceable by anyone at any time, anyone around the world can actually validate this certificate using blockchain, with the help of blockchain. And another domain of this blockchain is supply chain. One important domain where blockchain is most commonly used is supply chain. So supply chain is where what there is a lot of what problems in supply chain. The main thing is that lot of domains, actors coming in this supply chain. There is a manufacturer, wholesaler, retailer, customer. So many persons are in middle of the supply chain. Managing all these things is a very tedious task. So on reaching customer, they don't know where actually the product came from. In the case of retailer, they actually don't know who is the wholesaler, and the wholesaler doesn't know whether retailer is in the case for taking a case, retailer is seeing the egg you have delivered, the 100 egg was broken. The wholesaler have no proof saying that he actually delivered the good egg or something. There is no picture. Even if they have a picture, they actually maintained in their local database. So if you are using database here, everything we can, necessary information, we can store it in the blockchain. In the initial case, manufacturer can store the details, where how much egg he have produced. So what is the information about this form? All these things, the date of giving that particular egg to the wholesaler. All these things can be entered into blockchain, and the wholesaler can also introduce some information like when that particular pack reached wholesaler, is it reached in a good condition, how much egg they reached. Manufacturer may have sent 1,000 eggs, wholesaler may only get 900 or something. So all these informations can be entered into blockchain. The manufacturer and wholesaler can view this information, and on reaching retailer, he can enter the information, and customer, he can also validate all this information. Every actors present in this particular chain can actually view the information. So that is an important domain where blockchain can be applied. And also we are very conscious about the organic things, right? Users. So you on go to the supermarket, by scanning a QR code, you can see whether it is actually organic. Up to an extent, we can actually summarize this thing, where it comes from, what farm is it, what is happening in this farm. Most of the things, if government is also regulating it with, we can actually move a lot forward. And next is the art domain. So in the case of digital arts, there is no unique or representation or unique honorization in the case of digital arts. So this can be made using the blockchain. Blockchain have the programmable blockchain actually got a concept called NFT, non-fungible tokens, where you can represent these art forms uniquely with a unique owner. And in the case of financial applications also, you can make this financial system decentralized. So Bitcoin, you have already seen it, make the whole banking like system decentralized, right? So all the financial system like taking loan, chit funds, everything can be actually decentralized with the help of programmable blockchain. So we need a concept called programmable here. So with the help of programmable blockchain, you can actually decentralize loads of financial system. So DeFi comes under that. And next is the decentralizing organization. DAO, decentralized autonomous organization. So here we are actually decentralizing organization. There, in the case of DAO, there won't be any higher authorities who take all the decisions, and others doesn't have any say, and they just obey that decision. In the case of DAO, it is not like that. All the individuals in that organization have a say towards a proposal, have a say towards a thinking, right? So that is the case with DAO. So we can, with the help of a blockchain, we can decentralize. We can have a concept of decentralized autonomous organization. So in the healthcare also, we can actually use blockchain. So healthcare, the most important thing is that there is a lot of counterfeit medicines available in the market, and as a normal user, we can't understand whether it is a valid company, whether it is audited by the government, this particular medicine is audited by a government or something. So with the help of a blockchain, we can actually, like I said, on the supply chain, the manufacturer can actually enter his details, whether he is authorized by the government. If it is authorized, there is a government ID for his authorization, he can provide that. And the wholesaler can give their information. So I am a valid wholesaler. I only give supply this medicine provided by this particular supplier. And the pharmacist can verify all these things. And to the normal user, he can just with a QR code, he can just understand, okay, he doesn't need to know much information. He can understand whether the supplier is a valid one, this particular medicine is authorized by the government or something. So all these things can be done using the blockchain. And with the help of blockchain, we can also introduce a concept in healthcare, like the patients can control their records. Patients have a control over their records. So for instead of going to a hospital telling each things, he can actually a record is kept in a hospital, and the record is passed. Same record can be passed on the permission of the patient. The same record can be passed to other connected hospitals in the particular chain. So that is the case with healthcare. So someone raised the hand. Yes. So job opportunities about blockchain. So there are a lot of opportunities in blockchain. If you want to be a developer, there are blockchain developers who want to program. There are blockchain developers actually, Web3 developers. You can go as a blockchain developer, blockchain analyst, whether that particular application need a blockchain, which type of blockchain actually needed for a particular application. You can go for that. If you are interested in that particular job, you can go for that. Blockchain architects who are interested in architecting the network in that particular blockchain, and blockchain consultant. If company is adopting blockchain, so how way the company should grow with this particular blockchain, what type of projects they should adopt, what way of criteria they should adopt to increase their production and increase their income like that. And research and development, since it's a new topic, it is a very vast topic of research. Research still happening on the blockchain area. So if you are interested in research, there is a great opportunity in blockchain. And if you are not interested in programming, if you're not interested in the programming side, you can go. If you're interested in writing, you can be a content writer in blockchain, you can be a community manager. Everything is work with the community in case of blockchain. So you can be a community manager, content writer. So there are so many job opportunities in the case of blockchain. So that's all I want to share with you. So so someone raise the hand if you want to ask, please ask. So if you have any questions with the things I've shared,
Yes,
the
ma'am.
information I have passed, yeah.
So in blockchain, someone's identity is not revealed. So what to
What?
do for that?
Identity
In
is not
blockchain,
revealed.
yes,
Right.
there are happening some scams like money laundering and all.
So the identity is not revealed. It is actually proposed as a positive part of blockchain to some extent. So we doesn't have to reveal our identity. Our me myself is just an address in the case of Bitcoin network. So there are actually some yes, there are scams happening. So up to some extent. So to some agencies, it is actually traceable to up to some extent. So it is a feature. So but to some, if we are doing it through some exchange or something, it is up to some extent we can, or police or some agencies, some legal agencies can trace. So it is a kind of anonymity is actually they are proposing it as a factor in a feature in blockchain.
Okay, ma'am.
Yes. Any other
Hello,
question?
ma'am. I actually wanna like go with the path of blockchain developer, like where I want to become this, like building blockchain or building a crypto exchange like stuff. So
What building?
like working with the blockchain, like becoming a blockchain developer, like what is the steps and process to go with it?
Yeah. Okay, being a blockchain developer, you need to blockchain developer actually means developing decentralized applications on blockchain. So that is the main thing with blockchain developer. The networking part in the blockchain is actually dealt by blockchain architect. Blockchain developer also deals with building decentralized applications on blockchain. So you can actually do courses on blockchain. So there are in the KBA itself, we have several courses on blockchain. You can do courses. There are other courses also available. You can do any courses for being a blockchain developer in different blockchains. There are so many blockchains available. So Ethereum is the most first come programmable blockchain. So there are several programs in KBA itself to learn this blockchain development.
Okay.
Blockchain developer is not like building blocks or something, a network or something. Yeah. So I'm not clear. Are you asking something? Yeah.
Yeah, ma'am. I need the roadmap to be a blockchain developer from the
So
basic to
first,
the
I think
advanced.
some things you need. I think you in the first you need to know something about programming. It would be good if you are a full stack developer or something. So at least you need to have knowledge on some language like JavaScript, Go, or something. So if you in the case of Ethereum, it is you it will be good if you know about JavaScript. So then I will talk about Ethereum since it is the most first came programmable and most prominent programmable blockchain. And you need to know in the case of a blockchain, we have to write programs in the language they are proposing. So we need to write smart contracts. In the case of blockchain, we call it as smart contracts. We need to know how to write smart contracts on blockchain. So for each blockchain, there are separate language for writing smart contracts. So in the case of Ethereum, we need to know Solidity. So we need to know Solidity to write the smart contract. And after writing smart contract, we will study to deploy it in a blockchain network or put it in a blockchain network. And after that, we will develop a front end. So for example, I'm talking about a GPay application. I want to build a like GPay like application in blockchain. So I will write the logic in a smart contract, and I put that particular smart contract in the blockchain. And next I want to do is write the application, write the front end or back end for this application. So you need to know that. And after that, we will study. Next step is to study the connectivity between this front end or back end to the blockchain. So that thing you have to study. So in the development phase, you have to study. It would be good if you are a front end or back end developer, it would be good if you have a computer programming background, and you can go with any of the development blockchain development courses, and you can just study whole step, and after that get a certification or something, you can apply for the job. The thing is that you just the prerequisite is nothing but in knowledge on computer program. It would be good if you know something about the development, and in I only know about our courses provided by KBA. So by everything else is there on our course, dealt on our course. So after that, you can apply for a job. Is it clear? So I think it is clear. Can just that is all I want to share with you about blockchain. I think it was everything is clear for you. So tomorrow session you will deal with programmable blockchain. So thank you everyone.
Yeah. Thank you, Lakshmi. Yeah. Am I audible?
Yes.
Yeah. Just now I shared the feedback form in the chat box. Please fill the feedback form. It will be counted as to attendance to receive the certificate. And this recording video will be shared in the WhatsApp group. If anybody not yet joined in the WhatsApp group, you can join that group using the link that I shared in the chat box. Okay. If anybody is not yet joined in the WhatsApp group, you can join that group. So all the materials and recordings will be shared in that group. Okay. And the tomorrow session will be at the same timing, 11 a.m. Okay. Yeah. That's it, Lakshmi. Can we wrap it? Can we end the session?
Yeah. Thank you.
Thank
Thank you everyone.